Good morning, good afternoon, good evening, everyone. My name is Hugo, and our team put together a feedback system for the Cloud Security Office Hours community. As Don mentioned, we had a set of requirements to follow. So this is a brief overview of the project requirements. We're going to do an application UI walkthrough, the backend walkthrough, and then we'll dive deep into the technical aspects of the project. So for the feedback categories, we were asked to have 3 different topics to rate the sessions and also provide any feedback with a 500 character limit, and the choice of language was up to the developers. The architecture and availability, we wanted to ensure to keep costs low. So the application would only be deployed during the meeting time. So about 6 to 8 hours on Fridays, the application would be deployed. And we also wanted to make sure that it was server-based and it was a 2-tier application, and there were no disaster recovery requirements. The database, the requirements stated that we needed to have a cloud agnostic database that had weekly backups, a 3-week backup retention, and also feedback export and shutdown automation. It also required us to consider costs to make sure we keep it low or minimum or none across the board. And it also gave us some space to have bonus features that were up to the team. So we integrated certain features that we're going to showcase today. And with that, I'm going to pass my screen over to our application developer for the application demonstration walkthrough. So Ashrith, if you want to go ahead and share your screen.
Thanks, Hugo. Sharing my screen. I hope my screen is visible.
Yes, we can see your screen.
Okay. So before I get started, I would like to thank the team, the entire CSOH team, for giving me an opportunity to be part of this journey or to take part in building this application. So about me, I'm Ashrith. I currently work as a senior security research engineer. So about the application itself. So as Hugo had we had specific deliverables or specific requirements. We had to build a system, a feedback system, which would enable us to take feedbacks from all the users. So talking about the application itself, it's a 3-tier application where with the front end built using React, and the backend is built using a Python-based framework called as Django, and we're using Postgres database in the backend. So it's a 3-tier application. So how it works out is currently is with security also a major requirement for us. We wanted to leverage a kind of a provider which would provide security plus enable application to run very fast. So we went with Cloudflare basic tier plan. So what Cloudflare enables us to do is it gives us a basic web application firewall. In addition to that, it allows us to write some custom caching rules to increase the availability or increase the speed of the application itself. And also it acts as a CDN. So any specific front-end libraries, anything that has to be served is very fast because it loads it from the specific location from where the user is currently using. So to go over the application, so this is the front-end application. So when a user first logs in, this is what they would see. So right now it's mapped to a different domain. We are planning to move this to the domain. This is in its beta stage right now. So there may be few small hassles here and there. So please bear with me. So this is the application. This is the front-end login page. So on looking at the login page, it's fairly straightforward. The login itself would be happening over the user's Gmail account or the Google account at this point in time, but we do have plans to accommodate other kinds of logins in the future. So it's really straightforward. You come in here, so the login clearly shows that which week you're taking the feedback for. So in this case, we're taking the feedback for the 27th week or today's date. So you just log in. And on login, you see a simple form page. So this form basically gives an opportunity to take input regarding or give your feedback on certain aspects of the session which took place and really straightforward, looks into your looks into the relevance of the interest and other aspects of it. So let me just give some dummy data for now. So let's say this test feedback. So all the text fields are not compulsory, are optional in nature. So you can go ahead and submit it. So on submitting, you will be redirected back to the Cloud Security Office our application. In addition to that, a requirement from the team was we were 100% sure that we don't want to store any information regarding the user. We want to keep it as anonymous as possible. So we only use the SHA-256 or the hashed version of your email. That is to ensure that a user is not able to enter their feedback multiple times for a given week. So now that I've already entered my feedback, so let me say if I try to enter it again, it clearly shows that you've already submitted your feedback. So this is the front end of the application. Talking about the backend. So the team was we were very specific. We didn't want to go ahead and rebuild functionalities which are already available to us. So the reason why we went with Django was a tried and tested application which comes with a lot of security functionalities, and also had one additional requirement which we have was what a UI through which we could analyze the feedback given by the customer. So we want to leverage the Django admin page, which gave us the basic functionalities, and we can build over on top of it, right? So any feedback entered by the user would come under here, into the feedback section, right? Here, this is just the feedback which I just gave. And basically, you can have a look at all the feedbacks given by the users. In addition to this, you can go in and have a graphical representation of the feedback as well. So this is, say, you would have to look at overall what was the interest in the specific topic. So this is something as a graphical representation as well. There are a few more improvements which we are working on at this point in time for this, but this is how it would look at a high level. Yes, so in addition to that, I think the team will talk more about the security aspects of it. So we have ensured that there is, just to give you an example of the information which we're storing for a customer, right? So there's close to no information which we store for a customer. This is all we store at this point in time. So just the feedback. Yes, so yeah. Any questions on this? Any specific aspects of it? So to summarize, it's basically a 3-tier application with front-end built using React and Next.js, and the middleware or the backend built using Django. And this is a REST, we're using REST. So using the Django REST framework called as TRF or Django REST framework, and the backend is Postgres database.
So does every part of this app use HTTPS?
Yes.
That's good.
So that is one additional. So since we are using Cloudflare for this, that is the advantage of Cloudflare. So Cloudflare enables you to set up HTTPS fairly easily as well. So they have two options. One is origin, as in from the client to the server, to the Cloudflare server. And the other option is from the client to the Cloudflare server, from the Cloudflare server to the user. So ours is completely encrypted at this point.
Hey, Sharif, I've got 2 questions. The first one is, do you have perhaps an architectural diagram to kind of make it a little bit more visually digestible for some of the other folks on the call? And then a second question is, whose decision was it to use Django, and what was the thought process behind that?
Okay. I think, Hugh, can you share your screen if possible and show us the architecture diagram?
Yes, we have the architecture for the cloud infrastructure itself. We don't have an architectural drawing for the application components of it. And we can take a look at the cloud infrastructure architecture next. And to answer your question about using Django, that was the application developer's choice. If Asher wants to speak on why he chose Django.
Okay, yeah, so that's a very good question. Typically, this is a simple application that could have been achieved, using a simple Python API, right? Like maybe you can use Flask or Fast API. So the intention was not to rebuild things and use an application, use a framework that provided us with a set of guidelines or an ability to build on top of these things, right? So let's talking about Flask. Flask enables you to build REST services. However, it doesn't offer you guidelines. So when we're working with the team which consists of say 10 to 15 members, we wanted to ensure that we had a specific coding practices in place. We wanted to ensure that there was a standardization of the code. So using a framework enabled us to do that. In addition to that, Django uses the concept of ORMs, right? So which essentially prevents, and it's a trial and tested method. So a lot of it's been tested over the years. So it offers an additional layer of security. So for example, it has an additional concept of middleware, which offers a lot of additional security features, which typically doesn't come, or you have to build on top of any other framework which you go with. Like let's say you go with Fast API or Flask. A lot of these things has to be traditionally built. The third part of it is an interface through which you could go ahead and review the feedback given by the user, right? So the other option would be is to completely go ahead, build all the UI components, build the REST services to serve the data. However, since we wanted to deliver this application in a batch as soon as possible, Django made complete sense because Django already came with an admin panel, which offered some subset of the features which we wanted. On top of that, we leveraged a few JavaScript libraries and built the additional graphs on top of it. Does it answer your question?
Absolutely. Thank you very much. Anyone else
you.
have any other questions?
Yeah, I think.
Excellent. So now we're going to move on to the cloud infrastructure aspect of the project. We're going to take a look at the current architecture. Let's see as I share my screen. Here we are. So the application requirement or the project requirements stated that we couldn't use serverless options. So we went ahead with a Linux T2 micro free tier instance to host the application within the cloud and the Postgres database. Now zooming out for the entire architecture, if we look at the right-hand side, we have the user accessing the internet and being routed through Cloudflare into the Google single sign-on, which then they can access the application server that uses Elastic Block Store as the storage solution.
Hugo, are you sharing a screen?
I am.
Yeah, I can see the screen. I can see the
It's a
architectural
tab right next to Ashraf's screen.
Okay.
Oh, are both screens sharing?
Yeah, they changed the screen sharing sort of.
Yeah.
It's very confusing.
I apologize for that. Here, I'll stop sharing and reshare if.
Actually, Asher,
Actually-
if you could stop sharing, that would help. There we go. There we go.
Excellent. Sorry about that. Can everyone see my screen?
Yep.
Yep.
Excellent. Yeah, so the architecture, so taking a look at the right-hand side, where the user will begin its connection through Cloudflare into Google single sign-on, which then will be routed to the Ubuntu server within the cloud environment. The data within the Ubuntu server is backed up with the EBS server, and all of the feedback information is then sent to Postgres. We have several different security tools that we used and that we implemented, both AWS hosted and also open source third-party solutions. For within AWS, we leveraged the IAM component of the identity and access management. And then we also used the systems manager, session manager option to eliminate any unnecessary ports or connections. We also whitelisted Cloudflare's IPs, so only IP addresses that are coming from Cloudflare's IP addresses have connection to our system. We leveraged Scout Suite to audit our cloud infrastructure. We used OWASP ZAP or Z-Attack. Z-Attack proxy to dynamically test the application itself. We leveraged Terraform to templatize the entire architecture for easy deployment. And we also integrated Wazoo, which is a security information or security and information events manager with extended detection response capabilities. So moving on, for the teams and the roles and the teams that were put together for our project, we have various different roles ranging from cloud administrators and engineers to application developers to network engineers, system engineers, DevOps engineers, security engineers, data engineers, and project manager, with our key stakeholders guiding us through the entire process. So now we're going to dive into the different roles and their contributions. So the cloud administrators on the call, if you'd like to take it away from here.
Hello, good afternoon, or good morning to you over there. My name is Mary Adewale, and I am presently working as a business analyst here in the UK, volunteer for a not-for-profit organization. And yeah, I got to find this group through David in Ireland. And yes, I was lucky enough, the project was just starting. I'm new to AWS and to cloud. So really happy to be working on this project. So Crystal is the cloud admin lead. She's not here today, I guess. And Hugo has been a very great help as well. And he'll be presenting part of the cloud admin presentation. So our objective has been to enhance and secure the AWS infrastructure for optimal performance and compliance. And our key responsibilities were to grant access to the team, enforce policies, and to maintain the cloud infrastructure environment. Next slide, please. Thank you. So to grant access, we created new user accounts rather, and user groups. Also granted users access to the console. We set up passwords, and we provided the users with their login credentials as well. To enforce policies, we defined and enforced security policies for roles across AWS at the environment, and our policy assignment was based on the AWS managed policy by job function. Initially, we gave the least privilege permissions, then later adjusted as needed by creation of custom policies. So for each user group, we matched their policies also for unassigned users. Next slide, please. So this is just a screenshot or snapshot of our AWS environment. We've got a snapshot of our users, user groups, custom policies, and also the roles as well. And I'll hand it over to Hugo.
Mary, if I could
Oh,
ask you
thank
a
you.
quick question. So Mary, you said that you were fairly new to cloud and AWS as a whole. What would
Yeah.
you say you learned the most about from this project?
Great. I'd say definitely challenges were, I was new to the environment, but I think most importantly for me, being hands-on on the environment, I had some help from Crystal, who's already, I believe, an experienced system administrator as well. So I think just being hands-on and doing the job, creating accounts, and creating user groups, enforcing policies. Also, I think the most I did was to sort of reset passwords as well, because a lot of the time passwords expired. So I think that's the most, being hands-on, to be honest.
Awesome, that's great. It probably goes to show that you'll never have to look up how to reset a password in AWS with the amount of reps that you got, I'm assuming, which is great.
Yes.
Cool, thanks. That was the only question I had. Anyone else? Cool. Back to you, Hugo.
Excellent, thank you. So we also implemented least privilege on the different instances within the environment. So we're going to just briefly touch on the activities that we performed with the EC2 instance. We created groups and relevant users for the accounts that needed access to the actual environment. Not every user post deployment needed to access the EC2 instance itself. So we limited to the application developers and the security administrators, and we granted access specifically only to the directory that housed the application. The application developers group did receive pseudo privileges because they needed to navigate to the different system components to start the system control environment and whatnot. We also generated 20 character passwords for the EC2 instance users and assigned them to the appropriate group. When we first deployed the EC2 instance, we had the default Ubuntu super user account. So we went ahead and changed that password and kept it secret from all the other team members that initially had access to it. And for all of the users, when we implemented Session Manager, the Session Manager window dropped the user in a Unix shell, and for enhancement, and we implemented the Born Again shell for the users to be able to have more of a graphical representation of where they landed when logging in. And lastly, we installed a Wazoo agent for the extended detection and response capabilities to be able to monitor logs and collect any threat intelligence that that resulted from any actions on our system. And then for the Postgres database, we did similar activities. When we created the database, we listed out the databases within the Postgres and removed any unused databases that are created by default. We also created users and roles with strong passwords and changed the Postgres super user account that was initially used when it was deployed. We created 3 different roles. We created a Django application service role for the application service user account to interact with the Postgres database. We created the application developer role and the security administrative role. Those 2 roles currently only have read-only or select permissions on certain databases. They don't have access to any database that might contain the hash values of the user's email when they get generated through Google single sign-on. We removed default permissions from the public schema in the database and only granted necessary permissions, like I mentioned, for the roles and the users. And they also had very granular table level permissions to each role. Then we updated the Django application user accounts credentials within the file itself, with the env file, to communicate with the Postgres instance. I know that that's not safe practice to hard code a password within an environment file, but at this time, this was the simplest way in order for us to have a working application. As we move forward and continue to develop the project, we intend to mitigate this vulnerability. And now I'll hand it over to our DevOps team.
Hello everyone, good morning. My name is Rachel, and quick one, I'm also new to AWS, but not necessarily new to cloud. So the purpose or the scope of this project is to deploy everything Hugo just talked about, but through code. So it's easier, and we don't have to click so many buttons to deploy the infrastructure. I hope I'm audible, by the way. Yes, what are the components that we wrote in code? A load balancer, because we have two EC2 instances, which is virtual machines, Postgres database, VPC security group, virtual private cloud security group for security permissions, SSM for secure connection to the EC2 instance, which the reason for that is because I don't know if Hugo mentioned yet, but we're trying to take out SSH to the EC2 instance as a better security measure, because from the monitoring of the security team, we discovered that there were some login attempts to the virtual machines, and we wanted to take those out. So we decided to implement SSM as a security team. Now, what are the goals of using Terraform? So the ISC tool we used was Terraform. Pardon me. We had the option to use CloudFormation, but unfortunately that could not work out due to limited resource, and we just decided to go with Terraform since it's cloud agnostic scheme. That was why we decided to use Terraform. And what are the benefits of using Terraform as an ISC tool? Not necessarily Terraform, but just like going through the code routes, reduced manual configuration errors, faster deployment time, like I mentioned earlier, and improved infrastructure management. So if we do need to change something, or if we do need to add something, we can just type out the code for it, and then it can be reused multiple times without having to check for configuration errors. So next slide, please. You go. Okay, yes. So this is just like a screenshot of like the tree, basically the function. Now, how did this work? We made use of modules. Okay, so using Terraform, you have the option to make use of modules, and modules is just like a way of making your Terraform configuration reusable. So in the event that I need to do the same thing, I don't have to like copy the main file. I can just reuse modules and make minor configurations. That's like minor configuration changes. So let's say like name or specifications. So for the database, I can either just change the login credentials or change the storage allocation and all of that. So what are the key files? That's the main.tf files, which contains the main configuration instructions like IP addresses, variables and all of that. Then for variable handling, so like I defined all my variables, username, passwords, and all of that. Then output is just like an addition. It's not really like a function. Basically to display output, let's say I want to display the public IP of the EC2 instance I just created, I can put all of that in the output. So that's not what is in the output anyway. It was just like displaying the IP of the load balancer. And then secret.tfs, which is for handling sensitive information. So instead of hard coding credentials into the main.tf file, I just put like sensitive information like username and password in the secret.tfs file. Now the reason I use this is because like if we're trying to like push this Terraform configuration to GitHub, we can ignore it and then ignore the .tfs file, and then login credentials is not like in the public, which would have been a challenge if we're pushing it to, if it was in the main.tf file. So next slide, please. Now, what are the issues encountered? Module compatibility issues. So with Terraform, you have the option to either use publicly available modules in the Terraform registry, but I was having some issues with compatibility, so I decided to use mine. Now, the thing is, any other person can decide to use mine. It's not peculiar to just me, but it was just easier at the time, especially working with within the time we had to just make my own module. Then network configuration problems. I also had issues with like IP addressing and stuff. And then instance connectivity and security concerns that we addressed earlier, we had to switch to SSM. They had to create SSM policy in the Terraform config file to eliminate the use of SSH to the EC2 instance. Then future enhancements I'm sure like we've all noticed so far regarding DevOps, I'm only talking about like IC, which is infrastructure as code, but we do plan to use GitHub Actions, Engineers Future as a CI/CD pipeline, and then also add to the configuration file CloudWatch for monitoring our virtual machines and all of that, and then remote backend for storing Terraform state files. So when you like apply the Terraform config, usually creates a state file, which is just like a backup of like every resource you've deployed to the cloud. So by default, it stores on your local machine. And in order for if someone else wants to use the state file to make some changes, if it's not stored in a remote environment that they have access to, when they initialize the Terraform configuration, it is going to start the process all over, and we don't want it to start the process all over. We just wanted to make some changes, which is why we'll be using remote backend. I had some issues using Terraform remote backend configuration. I couldn't authenticate with their platform somehow. It kept kicking me out, and then it eventually banned me. So I just like left that bit out, and eventually we'll get to it. So that's all from me. Thank you, Hugo.
Yeah, thank you, Rachel. I didn't know you got banned from Terraform. That's a new one. But yeah, thank you. So moving on to the security engineer aspect of things, our security team was not able to join us today. So I'm going to go ahead and cover some of their key contributions. So we're going to look over the cloud security, application security, and then infrastructure security. So for the cloud security aspect of things, we use Scout Suite, a cloud security posture management tool that's open source and allows us to automatically identify and visualize security risks. So some of the findings that we looked at for the EC2, as you can see on the right, we have the before and after security implementations activities. So we closed the Postgres, SQL, and SSH ports to public access. We reduced the attack surface significantly. We do have the EBS volume is unencrypted at this time, which could potentially cause compliance and data security risks. So for our next steps with the EC2 instance, we intend to encrypt the EBS volume, continue improving the security groups, and restricting any other ports that might be of issue. It's important to enhance our overall EC2 security posture, since we want to make sure that our instance is secure and is not accessible to anyone out in the public. And we want to ensure we remain compliant to protect the data that we collect. For the RDS, there were a couple of vulnerabilities that we found. Instance backups were disabled, and it's a single availability zone instance. To reduce cost and leverage free tier for our test environment, we don't have any instance backups enabled, and we kept the RDS instance at within a single availability zone. When we deploy to production, we intend to have additional features that allow us to completely cover all of the requirements within the project. So switching into the IAM security scans, there were some issues that we found still that we removed stale credentials and overly permissive policies by implementing the concept of least privilege. The user accounts lack multi-factor authentication at this time, which is something that we must implement as we move forward. And the Scout Suite application did find some false positives, such as the insufficient password complexity requirements. The account that we're using for the test environment currently requires a very complex password, only retains the last 3 passwords, expires within 30 days, requires lowercase, uppercase, numbers, and symbols for the password. So it's pretty complex password management policy. However, Scout Suite was unable to pick that up. So yeah, as we move on to the networking side of things, when we deployed our instance, we had port 2280 and 5432, which is the Postgres IP or port number. And so that definitely raised a lot of flags. So to mitigate those issues, we closed down all access to public ports for 22 and 5432 and kept it within the VPC, and then further refined the port 80 for all the Cloudflare IP addresses. So that significantly reduced our threat landscape for our networking aspect of things. So as we move on to the dynamic application security testing, as I mentioned earlier, we used OWASP ZAP, the Z attack proxy application, which is a web applications security scanner that identifies threats such as cross-site scripting or SQL injection. It has several different modes, passive and active modes, that allowed us to identify a few vulnerabilities. So the test results, there were 2 medium risk vulnerabilities that were found. As Ashraf mentioned, the framework that we used allowed us to mitigate many vulnerabilities from the start. So it was secure by design mentality there. The active scanner found that there was a hidden file found, and also the user agent fuzzer capability. So we won't really drill down into that, but these were just something that we wanted to show the team for the application vulnerabilities. And then the passive scanner results, again, the application provides some information where we can reference and get some more information on how to mitigate the vulnerabilities. And lastly, for our security and information events manager and extended detection and response capabilities, we used an open source tool called Wazoo, which has a variety of different features, including compliance monitoring. It integrates the MITRE ATT&CK framework, provides a centralized logging analysis, real-time threat intelligence, and it allows to deploy scalable agents across different devices. Prior to us implementing the session manager, we noticed a spike in brute force attempts, password guessing, and on port 22. So this is a dashboard of the MITRE ATT&CK implementation of the application. And as you can see, we can see the tactics, the alerts over time, and it provides some information. It also has the capability of going into the log files itself and seeing which logs and more information on each alert. And then this is just, again, the same, a similar overview. You can see the PCI DSS requirements. I know we don't take payment card information, but it's definitely a good compliance framework to leverage, since it's probably one of the most sensitive or most strict compliance requirements out there. So yeah, as we can see on the graph at the top left, all of the different attacks ranging from our dynamic application security test, but also from out in the public with port 22 being exposed. So once we mitigated that, things got really quiet. And so some of the incidents that we saw, we drafted some reports. We have things that the vulnerabilities, the incidents that occurred ranged from attempts at accessing hidden files to SSH logins with whether it was brute forcing or non-existent users. And so with the recommendations, we mitigated those risks and further enhancing our security posture. And as we wrap up our presentation, we wanted to touch on the project management aspect of things and the resources we used. So our team met bi-weekly on Sundays through Zoom. We collaborated using GitHub for the code repository, but also managed the the different tasks using a Kanban board. We had asynchronous communication through Telegram, and all of our documentation, presentation, meeting notes, etc., are all housed within our Google Drive directory. And we used Amazon Web Services account to we had a test account for the for our project before we deployed to the Cloud Security Office Hours account. And some of the bonus features we implemented was Cloudflare for their security capabilities, as well as the content delivery network. We used Wazoo, as we saw, for the incident response capabilities, and then Terraform to develop the template for easy deployment when we transition to Cloud Security Office Hours AWS account. So one of the project requirements was get a cost of implementation. So we used some rough estimates here that allowed us to develop this estimate, a monthly cost of about $29. We highlighted some items. We'll be using the T2 micro, which keeps costs pretty low, and deployed for about 8 hours a week. And we'd require about 1 to 2 instances depending on the load. And then for the Elastic Load Balancer, we have 1,600 members within Cloud Security Office Hours. So we use that number for the average TCP connection per minute, since we expect to have traffic post Cloud Security Office Hours meetings spike due to the nature of the application. And we expect that connection to last for about 5 minutes. So this is on the expensive side of the implementation because of the high connection per minute, but we don't expect that much traffic on a weekly basis per se. So zooming out to the production architecture, there were some constraints that we had within our test environment as far as costs go to implement. So as you can see on the left, we didn't have the S3 bucket with infrequent access due to costs because it's not available within free tier. Same with load balancing and having an additional EC2 instance there. So those are the only changes that need to be employed in order for us to meet all of the requirements within the project scope. And again, for cost management, we leveraged free tier within AWS open source tools. We researched alternative solutions. For example, how do we close port 22 SSH for us to still be able to interact with our instance? And then we leveraged AWS credits. Shout out to Don for hooking us up with the $25 AWS credits that we found at the AWS Summit in DC last week. So we were able to implement that into our account as well. But yeah, if that's all we have for y'all. So if you have any questions or comments, the floor is open.